Hello, let's continue our advanced Sudoku series with Mama Bear by Jovial. This is puzzle number 8 of chapter 4 of the Sudokult Gospel document, which you can find in the description. You can also find a link to this puzzle in the description. As usual, I know what technique I'm looking for, but not where to find it. And let's get started right now. All right, let's get as much info as we can first. That seems useful. There's a 5 up here, but I don't want to mark 3 in this puzzle. What else do we have? We have 2 4s looking in here, and this 4 looks up, places a 4. These 2 4s look in, putting a 4 in one of these two. Anything else of note up here? Not really. Okay, let's look over here. We have 2 5s looking into here. There's a 5 in one of these two. 9s are looking into here, so there's a 9 in one of these two. 3 and 3 aren't good enough. Oh, I do have 2 5s looking down here, putting a 5 in one of these two. I also have 2 1s looking down, and this one looks in, putting a 1 here. That puts a 1 in one of these two. These 2 5s look down, putting a 5 in one of these two. These 5s now, they line up, so 5 in this row has to be over here. All right, what else do we have? 9, 8. We got the 1s, 2s. There's 2 2s here, so 2 in one of these two. 1 and 1. Okay, so there's a 1 in one of these two. These are kind of avoiding a lot of the digits. Did I miss anything here? So this cell, it can't be 1, 2, 3. It could be 4. Can't be 5, could be 6, 7. And then this cell can't be 1, 2, 3, could be 4, can't be 5, 6, could be 7. Interesting. Okay. Looking to see if I missed anything obvious here. The 2s, 1s. This 4 looks down. 4 is in one of these 2 cells. That points up, so that's actually not a 4. So 4 is in one of these 2. Oops, quarter mark. 4 is in one of these 2. This cell sees 4, 5, 6, 7, 8, 9. And so does this one. So yeah, this one is from 2, 3, and this is from 1, 2. Okay. Anything else like that? Oh, I have 2 7s looking up. Let's mark that. I got the 2 5s. This seems like, let's see, 1, 2, 4, 5, 6, not quite good enough. This can be 3, 7, 8, 9. Maybe I should focus on where the 7, 8, 9s are. These 8s actually put an 8 in one of these two. Do they do anything else? Not really. Okay, let's look at the 7s. There's just these 2 7s. And then 9s, we got 3 9s. Okay, so I missed that 9 is up here. Okay, and we got these 9s here. Okay. So I think we need to look for what we're looking for here. Today is a junior exo set again. We'll try to use set again. Looking for like the telltale grid of givens. Like we've got this grid here, but there's not, like maybe this one doesn't really line up very well. Let's see, these are from 4, 5, 6, 7. Sorry, not 7. 4, 5, 6, 8, 9. So where would we get another 4, 5, 6, 8, 9? I mean, this does get us 4, 6, and 8. Let's take a look at that. So let's take this row, or sorry, column. Let's take this column and this column. Let's make those green. So now I would want to capture 1, 2, 3, 4, 7, something like that. Not 4, sorry. 1, 2, 3, Just 1, 2, 3, 7. Can I get a lot of 1, 2, 3, 7 out of these rows? I mean, I can get a 1, 2 here. I can get a 1, 3 here, but it removes this 8, which is unfortunate. Yeah, I don't think that's it. Okay. Maybe we should look at how to capture with rows then instead of columns. This is really suspicious, to be honest, these two cells. And yeah, we can get a 5, 6, 8 out of this row. We can get a 4, 5, 6 out of this row, and we can get a 4, 7, 9 out of this row. These line up, and these line up, and then these are in kind of a diagonal. That's kind of interesting. Okay, yeah, and then they don't include 1, 2, 3. So where are we going to get 1, 2, 3s from? I think this column is a nice candidate with the 1 and the 3 here. We've got a 2 and a 3 here, and we've got a 1 and a 2 here. We only have a singular 1 here, so I think this is better. So let's start with this. Oh, I don't usually use blue. Do I use purple? Sorry. Let's use purple for that. Let's be consistent. So this is our set. Just to explain what the heck am I doing, in case you haven't seen any of the previous videos. I'm hoping you're kind of going through this series in order, but maybe you're not. So this is called set equivalence theory. The idea is green has 3 rows. It has covered 3 rows. So the green cells are 3 sets of the digits 1 to 9, because each row has 1 to 9 exactly once each. We also have purple that is 3 columns. 3 columns are also 3 sets of 1 to 9. So the green cells and the purple cells have exactly the same digits as each other. The same number of 1s, the same number of 2s, the same number of 3s. In fact, we know it's 3 of each. Now, what happens if I remove these overlaps, the cells that are both purple and green? Well, if I remove that overlap, I don't know which digits I've removed, but I know I've removed them from both green and purple. Therefore, green and purple still have the same number of each digit as each other. We just now don't know what those numbers are. We just know that they're still the same. So now what we can do is we can say, find any similar digits. So these 2 4s, we can just remove from both. We've still preserved that equivalence. We've got these 2 9s. We've still preserved the equivalence. Okay, so now we've got a 4, 2 5s, 2 6s, a 7, and an 8 in green. And I've got a 2 1s, 2 2s, and 2 3s in purple. Okay, so I have 2 1s, 2 2s, and 2 3s in purple. That means I need at least 2 1s, 2 2s, and 2 3s in green. If I were to put more than that in green, I just need to put more in purple at this point. But I know I need at least that many. I haven't accounted for any of those yet. So now here's the key with the exoset version of this. These external cells here, I'm going to make those blue. These 2 cells are from 1, 2, 3 already. So whatever these 2 end up being, we don't know if they're 1, 2 or 2, 3 or 1, 3, but they're 2 different values of 1, 2, 3. And whatever they are can't go here and can't go here. So these cells, I'll just make those, let's make those gray for a brief time. So the gray cells cannot have these blues in them, but we know that green has 2 of each. Has 2 of whatever this one ends up being and 2 of whatever this ends up being, but they aren't in these. So in this column, I can put 1 of each, and then the only other place I can put them is these 2 cells. So these 2 cells also need 1 of each blue, which means they are different, and it means they are kind of clones of these blues. Now I'm noticing in this column, none of them can be 1. The 1 is already accounted for in the column. So none of these can be 1, but we know we need both blues here. But if both blues are here, that definitely means that 1 isn't blue. Pretty sure that's right. Because if blue was 1, let's say this is the only blue that could be 1. If this was a 1, then I need 2 more 1s to go in green. I can put 1 of them here, but the other one has to be different. The other one has to be this 2, 3. So I can put 1 of them here, and in fact, one of them ends up here. But where's the other one going to go? The other one would have to go here, right? Because it definitely can't go in these by Sudoku. But if the other one went here, then now how am I putting 2 of this 2, 3 into green? Remember, it can't go in the gray cells, and I've now used up both of these for 1. So this one would have to go twice over here. That doesn't make sense. So actually, I cannot put 1 in these. This actually ends up 2, and this ends up 3. Which then means this isn't a 1. That places this 1 in 5. That means that's not a 5. That places this 5. Very nice. Okay, so now we know this is a 2, 3 pair. And then over here, we need 2 and 3, and then whatever else. Okay, well, we know we need 2 1s to go in green. I've placed one of them. Where's the other one going to go? It doesn't go in these, and it doesn't go in these. So it actually goes in here, and that actually joins the 9, making this a 1-9 pair. I don't think I need these grays anymore. I think that's just confusing. So I get a 1-9 pair here, so that's not 1, and this wasn't a 2. Okay, but that makes this a 1. That makes this a 5, this a 4, this is a 2. This is the other 6, 7. It's not a 6, though. That gives us the 7 and the 6. That gives us this 4. Okay. So now what do we... Okay, I feel like there's more we can do with this. And let's just do that exercise just to practice. So the other thing I'm thinking about is, can we actually put more 1, 2, 3s in purple? If we had additional 1, 2, 3s in purple, then the conclusion would be that there need to be more 1, 2, 3s in green, but we've already squeezed in as many as we can. We've got 2 1s in green already, and I can't put any more because this can't be a 1 because of that, and these can't be 1s because of that. So definitely don't get any more 1s in purple. 2s, I'm going to have one of them here, and then one of them in one of... Sorry, not here. That's not in green. I'm going to have one of them in the one that ends up the clone of this 2. And then I can have one more over here, and I will have one more over here. But that's it. So I can't have more 2s in purple, and then same with 3s. I'm going to have one of them here and one of them here. So I can't have more 3s. So all of purple is from 4 through 9. We can clean that up quite a bit. So let's just do that real quick. I don't think it gave us any singles, but certainly seems helpful. And then in this column, we know 2 and 3 are somewhere in here. So these can't be from 2, 3. They already couldn't be from 3. This one already couldn't be from 2. But let's just write it out. So these aren't 1, 2, or 3, or 4 or 5. So these are from 6, 7, 8. That one's not an 8. All right. I feel like this is really good progress. So this is a 4-8 pair. Oh, sorry. This can't be a 4 though, because of this 4. So this is the 8 and this is the 4 for the box. I wonder if we can figure out what the other... See, can we do any like crossing out? I guess I can cross out these ones. Let's pay attention to this set. I'm pretty sure the puzzle's basically done at this point, but I kind of feel like paying attention to the set. If I take a 2 and a 3 here, I can then remove this 2, 3 from green. So we can do that. So that 2, 3 pair is now removed from purple. Let's see. Are there any like pairs or anything in purple? We know a 4 is in one of these two. I don't know if we can really take care of any more at this point. It's probably not needed either. This is a pair that involves a 7. Looks like it's 7, 9. Okay, so that's not... We don't need the corner marks anymore. Does the fact that this is a 2, 3 pair, I think that's important, because these then can't be from 2, 3. They're also not from 1, because these one, yeah, there's a 1 in the box. So these aren't from 1, 2, 3. Do you see how that works? Like, if this was a 2, for example, then both of these would end up 3, but we know that they're a 2, 3 pair, so it doesn't work. So these aren't from 1, 2, 3. So these are from, they're not 4, 5 either. These are from 6, 7, 9. Oh, they're not 7 either. So that's a 6, 9 pair. And that means this is a triple from 2, 3, 4. And then similarly up here, these can't be from 2, 3 either. This one could be from 1. Interestingly. Okay, so that could be a 1. They can't be from 2, 3, 4, 5. So they can be from 6 or 9. Okay. Oh, this 6, 9 pair looks up. Okay. So that's a 1, that's a 9. So that's a 6 and a 1. Okay. That's not a 6. I think we're almost done. In fact, I might want to get rid of the colors, but let's see. I need a 2, 3 here. That's a 2, that's a 3. These are from 6, 7, 8. These aren't 6, so that's the 6. And these are a 7, 8 pair. We know the order. Okay, I still need a 2 in one of these two. Interestingly, I need a 2 in one of these two as well. What is this from? 7, 8, 9? Okay. I wonder if we can figure out at this point what our other digit is. I don't think we can. Or I don't think I want to spend the energy on that. It's more in line with what I'm thinking. What do we need in this column? We need a 2. We have the 3, 4, 5. We need 6, 7, 8. All right. I think I'd have an easier time of it if I just removed all the colors at this point. So I think that's what I'm going to do. And we'll just do normal Sudoku at this point. So 2, 3, and then 9 here. That's not the 3, that's not the 2. So the 3 ends up here. This triple might be interesting. We have 1, we need 2, 3. We have 4, 5, 6, 7. We need an 8. Okay. Really nothing. How about this column? We need 3, 6, 7, 8. This is 2, 3, 6, 8, not a 6. 2, 3, 8. Oh, it's not. Wait. Yeah, this one's not 2, 3, or 6. So this is only 8. That gives us the 4 and the 5. Gives us the 3, 2, and 4. This is not. Oh, this is the 6 and the 3. This is 7 and 8. This is 9 and 6 and 9. That's a 2. This is not 2. 3, 9 pair here. We get the 2 here. Gives us the 3, 8, and 2. Gives us the 7 and the 8. 7, 6, 8, 9. We're just plonking now. 9 and 7. 3 and 9. This is a 1. Over here we need a 3 and a 5. And then down here we need 6 and 7. And we're done. Nice. All right, that was a neat exo set. I really feel like doing the set version of it just makes it so much easier to think about what kinds of eliminations we can do. The fact that we needed to squeeze two 2s and 2 3s in, or really the fact that we couldn't put I think it was these cells. We couldn't put the 1 in any of them. I think it was these cells, actually. Couldn't put the 1 in any of them, I think was really important, because that gave us that these couldn't be 1. That's really interesting. It gave us that these couldn't be 1. So yeah, that seemed like a key deduction there, and I'm pretty sure it was logical. It ended up working out. So let me know how you did on this one. And of course, if you enjoyed this, why not leave a like, subscribe, and a kind comment below.